Hello, everyone, and welcome to Best Practices for Math Classrooms at Chaparral High School. I'm Jake Pano, a teacher here at Chaparral High School. Today, we need to address a couple issues going on in our school. And currently, we have two types of classrooms in our math department. We have an old school type of classroom, new school type of classroom. We have classrooms where the teacher stands in the middle, the desks are in rows, and they lecture, do examples, and then students do independent work. And then we have other classrooms where the desks are set up in groups. Kids are working on problem solving, completing tasks, communicating, collaborating. And in other terms for old school and new school are teacher-centered versus student-centered. And according to the National Council of Teachers of Mathematics, the NCTM, they state that mathematics lessons should be centered on engaging in solving and discussion tasks that promote reason and problem solving. And DeMuro, in his article, Best Practices in Mathematics Instructions, Teaching for Understanding, states that to be successful, learners cannot be passive spectators that just listen to a lecture. They must be actively engaged in the learning process so that they can incorporate what they learn and make it part of themselves. Both of these literature reviews lean towards recommendation of student-centered classrooms as being a best practice. In 2010, the NGA Center came out with these 8 standards of mathematics practice for students. These 8 standards we should all be familiar with. We have posters in every single classroom. These 8 standards represent what students should be doing while learning math. They are to make sense of problems and persevere in solving them, reason abstractly and quantitatively, construct viable arguments and critique the reasoning of others, model with mathematics, use appropriate tools strategically, attend to precision, look for and make use of structure, and look for and express regularity in repeated reasoning. We need to make sure students are using these standards while working in the math classroom. And to do this, okay, the NCTM, okay, in their book, okay, that we all have a copy of, okay, Principles to Action, state these 8 mathematical teaching practices. So if we are following these 8 practices while designing our lessons and running our classes, then we will be ensured that the students are performing their standards of mathematical practice while learning math. Okay, these 8 mathematical teaching practices are establish mathematics goals to focus learning, implement tasks that promote reasoning and problem solving, use and connect mathematical representations, facilitate meaningful mathematical discourse, pose purposeful questions, build procedural fluency from conceptual understanding, support productive struggle in learning mathematics, and elicit and use evidence of student thinking. So what does this mean for our instruction? Okay, pause the video here. Okay, think about this question before resuming the video. It means that we need a shift to student-centered classrooms. All teachers need to move this direction. Teachers are no longer the keeper of all the knowledge in the classroom. Teachers need to allow students to collaborate and use technology to research, make connections, and discover new knowledge. Teachers should not just tell students how to do every step of the math. They need to allow students to have productive struggle. Always remember to summarize students' findings to the whole class to make sure all students make the connections. This shift, okay, will make a huge difference in student learning. One way to make this shift is to use rich task-based lessons. Okay. Just assigning procedural textbook problems will not allow students to use the SMPs. And if teachers are lecturing and then assigning book work, they are not using the MTPs. Finding or making the right lesson is the most important step in being an effective math teacher. Using the best teaching strategies will not make a bad lesson more effective, but students can still learn with a good task-based problem even without the best practices. Finding and writing rich task-based lessons will not be covered in this PD, but you can find information in Julie Dixon's book, Making Sense of Mathematics, okay, teaching high school, okay, that everyone received at her PD that we attended. So we have already been trained on how to write, make, and use rich task-based lessons. Okay, so use that book for review, okay, or email me any questions. So based on the standards of mathematical practice and the mathematical teaching practice, okay, we have best practices within the classroom, teaching strategies. Here's a list of 10, okay, that I like to use in my classroom, okay, that help promote the SMPs and the MTPs. Okay. The first one is group activities, followed by mini whiteboards, notice and wonder, use of appropriate technology, multiple representations or solution pathways, gallery walk or group share outs, the use of history or real world applications, a flipped classroom, interactive lessons, and intervention strategies. Okay, and to go over these instructional strategies that I like to use, I want to use just a task that I use at the beginning of every year for Algebra 2. It is based solely on Algebra 1 standards and geometry standards. So some of these skills the students have not seen in a while, but that leads to some of the other strategies that I'll be using, okay, while doing this task. Okay, the link is for this task is provided in the slides. Okay, so you can download the PDF, so you have the whole thing here. But take a second, okay, pause the screen, okay, take a second to read the prompt, okay, or download the PDF that is linked in the slides. Okay, so the first strategy, okay, is group activities. Okay, why group work? Why do we need to do this and incorporate this in our class? Okay, because when we're working in groups, okay, students are collaborating. And collaborative thinking leads to more creative problem solving. Okay, it teaches the 4 C's, okay, of 21st century learners. That's communication, collaboration, critical thinking, and creativity. Okay, when working in groups, students have to explain their thinking. Okay, that was the last MTP, to get students to explain their thinking. Okay, it increases engagement. When students are in a big class setting, it is easy for a few kids to hide, sit in the back, not be engaged in the class discussion. But when they're small groups, okay, they hold each other accountable, and it makes the engagement process go up. When to use group activities, okay? You can't use group activities for every lesson, okay? But I like to use group activities on tasks that require a lot of past knowledge to solve, okay? So that when there's lots of connections being made to prior math, that is a good time to use a group, okay? Because lots of collaborative minds, okay, can draw on their past knowledges and help each other to remember. When I provide open-ended questions that have multiple solution pathways, okay, working in groups allows creativity and the discussion, okay, people see things differently and they can open up other ideas for students. on discovery lessons where students need to make connections and draw conclusions. So if the task is designed for the kid to discover new math by making connections or recognizing patterns, okay, working in a group, okay, allows them to discuss and problem solve and make connections to their prior math together. Okay, and basically, whenever you want students to explain their thinking, okay, put them in groups, right? Have them talk to each other, right? If you try to do it as a whole class, you only get to hear one or two voices. But when they're working in groups, everyone's voice is heard. So group activities help with this. Okay. How do you make group activities successful? You can't just tell them to go get in groups and work. Okay? They have to be trained on how to communicate and collaborate with each other. Okay, we need to be able to produce productive discourse, okay, which is MTP number 4. Okay, so we have these, every classroom at CHS has these norms posted on the wall. I believe it is important to teach these norms, okay, and the norms are very simple, but I will explain my thinking. Okay, what's this mean? So when I have an idea, okay, about how to approach the problem, I need to be able to explain my thought process to my group members. Okay, when I'm explaining my thinking or my idea, everyone must be listening. Don't interrupt. Be polite. Let them get their thoughts out. Okay, and when they're finished speaking, that's your turn to say something if you don't understand. Okay, or you disagree. All right. We need if the kids could follow those 3 things, group work, group discussion will be on task and productive. And when a group stops being productive, that happens. Everyone in the group looks at each other and they don't know what to do next. Okay, remind them of these norms. Explain your thinking. Just what are you thinking about? Okay, or maybe that's the time for a teacher to pose a purposeful question, which was MTP number 5. Okay, get the conversation started again with the key question. All right. The one thing that the NCTM also provides, okay, in this book on Principles to Action are 5 practices for effective whole class discussion. And those are anticipating, monitoring, selecting, sequencing, and connecting. Okay, going over those 5 is a whole nother presentation within itself, a whole nother professional development. But when you design a lesson and you do these things while running the lesson, it's going to be a very productive lesson. Group activities and the zipline task. So how does this relate to the task? Okay, for this task, I would definitely use groups. Okay, it requires a lot of prior knowledge, okay, and allows for multiple solution pathways and multiple representations. Okay, so using groups, okay, would be a very important part of making this task successful. Okay, I would put a strong focus on the norms. Okay, with the emphasis on student explaining their thinking. So as soon as they have an idea of how to approach a question in the task, okay, make sure they're explaining their thinking. This is a skill that kids need to work on. Okay, just looking at question 1 in the task and ask students to turn them to talk about the steepness of math, and you have to turn it into a sentence. Okay, so they have to explain their thinking. How does the steepness of this line represent a rule or regulation? So they could talk about slope, they could talk about angle measurements, but they need to be able to put their math into context. Okay, so group work, bouncing ideas, making sure what they're saying makes sense. Okay, group work is needed for this task. Okay, the next strategy is mini whiteboards. You see this strategy in elementary schools all the time. These work great in a math classroom at all levels. Okay, it is a quick way to check for understanding. It engages everyone in the class because everyone is holding up their whiteboard. Okay, when one person doesn't hold up the whiteboard, Okay, we wait until they get it up so everyone's engaged. Okay, it helps to address misconceptions. So when you see the same mistake repeated on several whiteboards, then you know that something is wrong. There's a disconnect, there's a misconception, and we can address it and fix it early on in the process. Okay, and students look around, they look at other people's responses. So they know that a lot of people are getting this answer. Why? And it leads in there, oh, that person did it this way. It leads to discussions, okay? It leads to seeing multiple representations of the work, okay? When do I use mini whiteboards? Okay, to be honest, I use them mostly for warm-ups, okay? Just to check prior knowledge of prerequisite skills that are about to be used for the day. But that also holds true before a task. So if you know that the task is going to require a lot of factoring, okay, then a good lesson to do before the task would be mini whiteboards on factoring. Make sure the kids understand that skill because it'll be used during the task, okay? Or if you taught a lesson that was heavy on procedures, okay, using it at the end, kind of like an exit ticket type, show me how you do this just for a quick check before they work independently. So whiteboards are a key part. And so for this task, for the zipline task, I would use mini whiteboards. Okay, before I pass out the task, I know that on question 3, it asks them to write the function of the zipline in slope-intercept form and standard form. This is something they have not done since Algebra 1, so for over a year. Okay, most of them have forgotten standard form. Most remember y equals mx plus b, but a lot of people forget standard form. So just doing a couple questions, changing from standard form or from slope-intercept form to standard form, kids will see a few, then they'll recall how to do it. From a graph, how do you write it? Just quickly do 2 or 3 questions, refresh their memory on that skill, and it won't take long because I get to look at all the work and address some stuff and then be able to get them started on the task. Okay, this next strategy is very underrated. I love it. It's called I Notice, I Wonder. I'll use it on almost every word problem, any problem with the graphs when we're interpreting graphs. What it does is it takes a problem that has a lot of information and it slows the thinking process down. Instead of just jumping right into it, let the kids actually think about the problem. You ask them to write down everything they know about the problem, any information that was given, okay, anything about a graph, okay. They write everything down and then they say, what do I still need to know? What do I still wonder? What information is missing? And then they write down all their wonders. Okay, then I'll have them share out with the class. If you want to pause this video right now, go to the slide. There is an example of what a notice and wonder looks like in the class right there. So just click on the video link and you can watch an example of a teacher using an I notice and I wonder. And they also talk about how it works in their classroom. This is something I would definitely use for this task. This task has a lot of information before it even asks a question. Okay? I would give them the prompt and the picture and have the students read all of this. Okay, and after they've read the first page and haven't sent any questions, I would have them in their groups write down minimum 5 things that they noticed about the prompt, about the question, about the prompt, about the graph, and then 5 things that they still wonder. Since there's no questions being asked, a lot of times this wondering will lead to some of the questions that I'm going to ask. Okay. This is to give them about 5 to 10 minutes. If they're still going at 10 minutes, give them a few more minutes. But if the conversations are starting to die down, okay, then that's time to start sharing out with the class. You just write down on the board all their notices, okay, all their wonders. And now, before they even get the questions, They have all this information that's been clarified, okay, for them to begin actually doing the math and problem solving. I love this strategy. Okay. Another big one for a class is using technology, but it has to be used appropriately. Okay, here I've got a list of appropriate use of technology and non-appropriate use of technology. Calculators are a great tool to have in class. Scientific graphing, anything that they help the kids do the procedural stuff. It speeds it up. It increases accuracy, and it doesn't take away from their understanding of how to do the math. It just helps them calculate numbers. Okay. Khan Academy, YouTube, kids can research how to do anything, look up examples using these websites to help them understand on their own. And I'll talk about flipped classrooms later, but it's a great way on their own for kids to learn how to do some math. There's two programs that I love, Desmos and GeoGebra, that you're allowed to create activities and have the kids study graphs and movements. It's very visual. It aids the students' recognition of how the equations are related to the graphs, so connecting multiple representations. Okay. Google is a great source if used correctly. It's on here both. If you're Googling prior knowledge, like I'm looking up a formula that I know I should know, but I've forgotten, okay, that's okay. But if you're trying to just Google the question, type in the question word for word, and see if Google produces an answer, that's not using technology appropriately. Okay, and discussion boards are a great way to get kids to explain their thinking and discuss other people's thinking. There are lots of technology out there that are not always used for the purpose of their design. Photomath and Socratic are both great apps that if you're stuck on a problem, they'll help you work through it. But many students just use them to complete their problems, just take the picture, get the answer, copy it down without actually thinking about doing the math. And even worse is just texting other groups or students for answers in class. Those are all non-appropriate ways of using technology. And if Google could answer the question or Photomath could answer the question, it's probably not a good task-based question that's going to elicit a lot of original thought. So you should think about creating better problems. Of course, sometimes you have to do procedural problems. It's important for kids to understand the procedures and develop those skills, but it shouldn't be only on those procedures and skills. For this task, I would use technology. I'd provide it for them. It wouldn't be mandatory, but I always provide one Chromebook for the group. And again, there's the distance formula that comes up. So a lot of people will look at the distance formula because they haven't used it since geometry. And some people will go right to Google, YouTube, or Khan Academy and say, how do you find the distance? And then they get different ideas how to find the distance. Question 11 asks them to find the intersection point of two zip lines. So using Desmos or GeoGebra would be a great way to graph some lines and visually see that intersection point, so they wouldn't have to do it algebraically. So the technology is there for them on this task. They can solve the problems without technology there, but it's there for the assist, and it helps them move along in the problem. Now, the next strategy is make kids represent math multiple ways. Make kids solve problems in multiple ways. Okay, this is very important because different representations allow for connections to be made. This is the teaching practice number 3. If they can see multiple representations and connect it to their prior knowledge, it allows them to build off that prior knowledge to gain future knowledge. It allows for creativity. right? If I'm a teacher who has my favorite way of solving a quadratic and I only teach them that one way, okay, uh, later on when they're asked to solve and it lends itself towards a different strategy, it doesn't give them the options to decide which way is best for that situation. Um, Kids are very creative when recognizing patterns and how they see things. And if you're looking at patterns and you only show them the way that came to your mind as a teacher, you're stifling their creativity, and you should allow them to explain how they saw. Um, it's a great enrichment tool. Some students will finish the problems very quickly, and then if you just ask them, explain it a different way, do it a different way. Can you represent it graphically? Okay, and it gets their minds going and takes their understanding to the next level. And it creates discussion. Okay, when you ask kids to do something two ways, okay, or you compare two different solution pathways, it's a start for a great conversation. And then kids are explaining their thinking again, which is mathematical teaching math practice number 8. Okay, get kids to explain their thinking. In this task, I mean, if you just look at the first two problems, there are multiple ways to solve all these. And these are all examples that I took from my students. When talking about steepness, I had students use just the slope, rise over run, and then they turn that into a sentence. I had some people measure the angle using a protractor. Again, I provide these tools on their group, so it kind of sparks their thinking. Oh, there's a protractor here. Can I use this? Right? And then they describe the steepness based on angle of elevation or angle of depression, whichever one they measured. Right? You could also use trig, okay, and use the trig ratios to find the angle measurement. So you see all these different pathways, and when the students get a chance to see these and they're amazed by the creativity and the different ways to solve the same problem. Question 2, distance, right? That leads to the Pythagorean theorem, the distance formula. You could set up a proportion from the key on the graph. Just measure out 2 inches on the graph equals 9 meters here. So what is that going to convert when the whole thing is this many inches? Again, you could use trig. So just so many ways you can solve the problem. And then on question 3, I specifically want to elicit multiple representations. I asked for slope-intercept form and standard form, okay? So they're thinking about different ways to represent that same equation. Okay, the next strategy is a gallery walk. Okay, I love this one too. Gets kids up out of their seat and it allows them to see other people's work. It allows them to critique their thinking, and it allows them to provide feedback and also to receive feedback. And it creates conversations because while you're looking at other people's work, you're discussing what they're doing. And then it allows for reflection because you come back and you finally end at your own and you see all the feedback that you received and you get to reflect upon your own work. Again, if you want to pause this video, go to the slides and watch the video I have linked there. It shows an example of a gallery walk in a classroom and talks about all the benefits to doing one. It's a great tool. I know it does take a lot of time with 36 kids in a classroom to walk around from each group and give them time to look at each presentation, but it is well worth the time. And I would definitely do this, okay, with this task because of all the different multiple representations that I see during class. It would really be selfish of me if I did not allow students to see all the work that I saw. So the gallery walk allows everyone to see the work and do this. If time is concerned, because this task will take some time, time is concerned, you can maybe just pick 2 presentations that you saw, 2 student groups that you saw, and you wanted to share their work to make sure everyone saw these cool, creative problem-solving strategies that these groups used. you can select certain ones if you don't have time for the whole gallery walk. But if you have time, I highly recommend it. Okay, another strategy is using history and real life applications, because we've all seen this question. We've all heard this question. When will I ever use this, right? So, well, there's lots of applications to math. I mean, science is just applications of math. Economics is just applied math. So you find how the math in the class is connected to the science, to real life, to economics, and you gain their interest, okay, by relating it to something that they see in the real world. Another thing that I'll do again, high school does not really have the time built in to do this, but if you can teach the history of the math, it gets kids interested in where it came from, why people thought about this, and their problem solving, where it started from. It gets them engaged in the lesson, and they see the application of the math. So history and real life problems are a great way to engage students. And that's what this task was. Okay, this task was a real life application, right? You had to take all these rules and regulations and apply math, okay, to create more rules and regulations, to build, to code. It really gets the kids to attend to precision when they've got to follow these regulations, which attending to precision is a SMP, SMP number 6 to be precise. I usually do not do the history piece with this assignment because there's so much math, but you could focus on the Pythagorean theorem here. Pythagoras was a very interesting guy, had a cult that followed his thinkings. He did math that related to music. He found the connection between math and music. He obviously discovered the Pythagorean theorem, which created a problem because with the Pythagorean theorem came the introduction of irrational numbers. So there's so much math around this that it's very interesting when students see this and how it relates back to what they're doing today. Okay, the flipped classroom. This is probably more relevant today with us going to online, because I don't think a lot of teachers use a flipped classroom. But what a flipped classroom does and why you want to use one is it makes the content accessible outside of the class. I know you always have the textbooks and people can look at their notes from class, but what if you just presented the notes, you made the notes accessible through either video or slides, and you let the kids access those notes outside of class? Okay, obviously they'd have to access them before you needed it in class, but that gives them time to look through at their own pace and figure out the math. It provides more time in class to problem solve and to work on tasks. If you're taking time just to do notes and it takes 30 minutes for you to give direct instruction on they're just copying off the board and examples, they could have done that at home, okay, through a video presentation that you made or you found on YouTube, or presenting the presentation slides to them. With distance learning, this flipped classrooms will be required through our asynchronous learning part. Kids are going to have to do some work on their own because the live face-to-face time is very limited with our conferencing calls. So the more they can do on their own, the more valuable these conferencing calls and synchronous time could be. So how do you do a flipped classroom? You just give the students access to the notes, right? You share them. You can make them editable or non-editable through our Google Drive. You could post a video of yourself going through the notes so they could watch. You could find other videos online. The problem that some people have with the flipped classroom is you tell the students to do this, they don't, they come back unprepared. And they could say, well, I just didn't understand it, when you really know that they didn't do it. So to counteract that, there are some great websites out there that will help you monitor their progress and check for understanding as well. I recommend Edpuzzles. You could upload a video of yourself or find a video, pause the video at certain points, insert questions. They have to answer those questions before the video plays, and then you see their responses. So it's making sure they're actually doing it, and you're checking for understanding. Khan Academy, very similar. Watch a video. They have questions that follow right afterwards that provide instant feedback if they're doing the problems correctly. So flipped classrooms are very beneficial, and they create a lot more time. For this one, I usually just stick with the mini whiteboards, but if time is an issue and you don't have time to do mini whiteboards in class, just flip it. Have them do the procedural stuff, review at home, give them a video on writing things in slope-intercept form or using the Pythagorean theorem to find distance. And then have them do that before you introduce the task, and this will save some time in the classroom, because this task is minimum 2 days. If you're doing whiteboards and the gallery walk, it's at least 3 days for them to get through all these questions and discuss and share out all their findings. So a flipped classroom might help you with that time management piece here for this task. All right, now sometimes as a math teacher, we have to do direct instruction. Maybe time restraints forcing me. We don't have time to do a discovery activity. I need to just tell you the information. Sometimes the information itself, it's so abstract that you need to just instruct and show the students how to do it. Sometimes you just need to do it after a task to make sure everyone made the correct connections. Because you wouldn't want them to do a discovery task, draw a wrong conclusion, and then think that their conjecture was right. So when you have to give direct instruction lecture, you need to make it interactive. These kids need to be engaged. If I'm just sitting there talking to them, okay, kind of like right now as you're listening to me, it's easy to be disengaged and not listen. But one technology tool that I love and I want to share with you guys is Pear Deck. It's very easy to use if you use Google Slides for your notes. It makes your Google Slides interactive. Again, you can pause here and watch this video if you've never used Pear Deck before. There's a little 9-minute video over there that introduces you how to make sure it's installed as an add-on on your Google Slides and how to use it and make your slides interactive, very quick. And it just makes sure that that kids are engaged. Okay, you know they're engaged because they have to respond when the slide opens up and asks them a question. Okay, you could use it to multiple choice questions, free response questions, little yes, no, poll survey type questions, but it lets you know who's answering, what they're answering, okay, so you know that students are engaged. Otherwise, your direct instruction is probably only being listened to by half the class, if that. And I wouldn't really do this with the zipline task because everything was reviewed, but if I'm doing a task that has new stuff, I would do this at the end of the task after everyone's presented and done their work. I would summarize all their findings with direct instruction. Okay, the last strategy is you must have an intervention strategy ready. Okay, students are going to come to your class with gaps in their learning. They may fall behind due to illness, absences, okay, or the math's just getting too complicated. You have to have an intervention strategy. We have our intervention period and built into our schedule where we could intervene with the kids and pull them in and work with them one-on-one. But that's just catching probably what they're missing right now in your class. For the kids with those big deficits, okay, you should have a strategy or tool to use. And at Chaparral, we have Math Excel, access to Math Excel through Pearson. And Math Excel is a great way to get kids to work at their own pace on as many problems as they need with each problem, there's an explanation, a video, examples to walk them through these skills, so you don't have to sit there with them and hold their hand on every single skill. The computer program will do that for you and guide them through that and get them caught up at their own pace. So during intervention period, you give everyone a Chromebook that needs it and let them work on through this program. The key to this is identifying students, okay, with these gaps early. This task will help with that because it is all prerequisite skills. So if I notice a student, even after the mini whiteboards or flipped classroom and collaboration, still cannot write an equation in slope-intercept form, I know they have a gap, and I need to make sure that that gets addressed. And so I get assigned that section in Math Excel, and kids can get more practice at writing equations in slope-intercept form. So if the computer is not enough, you will have to design other lessons to help work one-on-one. But the computer is a great way, Math Excel is a great way to get kids caught up on their gaps. All right, so thank you for your time, and hopefully those strategies help. If you have any questions, you could always ask me about how to use those strategies. If you want to see them used, you could always come observe me teach a class. But what we've learned is that math classrooms must become student-centered. Okay? They need to focus with student conversation, collaboration. Students need to be using the SMPs during class so that they are learning the necessary contents while improving on their 21st century skills such as communication, collaboration, critical thinking. It's essential that students are doing this in our classrooms. So these strategies help, but it really starts with getting that good lesson, a good task-based lesson, and then applying these strategies. Okay, thank you for your time. And again, if you have any questions, you can contact me through email. There's my work phone and my cell phone. You can send me a text. We can set up a time to observe each other. But these are great strategies that we need to continue to work on. So thank you, and have a good day.